Namaste students. Today we are going to start with very important topic, that is integrals. If you remember, when you did differentiation, we were telling you time and again do this topic properly because it is a base of your integration. Integrals, or we say integration, it is a base for integration. Alright, so that means these two topics, differentiation, integration, are the part of your calculus and play really very important role in mathematics. So we are going to start with integrals. Now when we were saying do differentiation properly because it is a base for integration, that means there is a connection between these two. There is a connection between differentiation and integration. There is a relation between differentiation and integration. Let's check what that relation is. For example, differentiation, you all know, you have already done continuity and differentiability. You have done application of derivative. So we are going to start with the new unit, that is integrals. Alright, now we'll start with example. For example, if I say y is equals to x raised to power 4, what is dy upon dx? That is 4x cubed. If I say y is equals to x raised to power 4 plus 2, what is the differentiation? That is 4x cubed. If I say y is equals to x raised to power 4 minus 1, what is the differentiation? 4x cubed. If I say y is equals to x raised to power 4 plus half, what is the differentiation? That is 4x cubed. What do we observe from here? What do we observe? 4x cubed is differentiation of function x raised to power 4 irrespective of any constant. Whatever constant is added to it or subtracted to it, the differentiation is same, that is 4x cubed. That means when I say the differentiation of these so many functions is 4x cubed, that means there is something much more of the depth in differentiation. There comes integration. Now it means this is a function and we know the differentiation. Alright, the differentiation is same for all these functions. Differentiation is the function is given to me, I find dy upon dx. Now what is given to me? Now the differentiation would be given to me. I have to find out f of x. That means I have 4x cubed, 4x cubed, 4x cubed, 4x cubed. I have a differentiation of these functions. Now I need to find out this is the differentiation of which function this differentiation belongs. Is it clear? That's my target. That means f dash x is given to me. I need to find out f of x. It means I have f dash x and want to find f of x. Is it clear? So that means integration is reverse process of differentiation. It is a reverse process of differentiation. In differentiation, function is given to me. I need to find out dy upon dx. And we observe that 4x cubed is a differentiation of all the curves, all the functions of the type x raised to power 4 plus irrespective of a function. Say that's C. That's a arbitrary constant. That's arbitrary constant. Is it clear? So in integration we would be given f dash x, we have to find out the function. That means we are doing reverse of what we were doing in differentiation. Is it clear? So integration is the reverse process of differentiation. Integration is the reverse process of differentiation. So now how to do it? It means obtaining x raised to power 4 from x raised to power 4 from 4x cube, or we say obtaining x raised to power 4 plus 2 from 4x cube, or we say obtaining x raised to power 4 minus 1 from 4x cube, or if I say x raised to power 4 plus 1 by 2 from 4x cube. This is what we are going to do in integration. In differentiation, this is given. I have found the differentiation. Now in integration, the differentiation is given to me. I need to find out the function. That is why we say the integration is a reverse process of differentiation. So that's why integration, the other name is antiderivative. The other name is antiderivative, or we say primitive. So these two names also you need to keep in mind. It should not happen that something they say find the antiderivative and you start thinking, oh, what's antiderivative? That's the name of integration, because it is a reverse process of differentiation. It is a reverse process of differentiation. Alright, now it means if dy upon dx is 4x cube, then y can be any one of it. It can be x raised to power 4, it can be x raised to power 4 plus 2, x raised to power 4 minus 4, or x raised to power 4 plus 2, and many more. So that means then y, if I generalize this, y can be x raised to power 4 plus c, and I told you earlier, this is called arbitrary constant, which may change, which keeps changing. Arbitrary keeps changing. Is it clear? So that means in this integrals, differentiation is given to me. I have to find the function. That means differentiation and integration are reverse processes of each other. Reverse processes of each other. We have two branches of integrals. One is indefinite integration, which we'll be doing it now, and other is definite integrals. Definite integrals. Is it clear? That will be doing by passage of time. First of all, we will do indefinite integral, and then we are going to do definite integral. Indefinite integral means 4x cube is a differentiation. I know the function is of the type y is equals to x raised to power 4 plus c. What exactly c is, I have no idea. That is indefinite. Alright? I have no idea what c is. C may have any value. But when we will do definite integration, then what does definite means? I know exactly what it is. Fine, there this arbitrary constant will not come. I am definite about the answer, so that's definite integration. Indefinite, I don't know what exactly the c is, so that's indefinite integration. Alright, now we'll do some important terms which are related to your integration. Terms related to integration. Some important terms, those are symbol and terms, and what does it indicate, the meaning. Okay, first of all, this is the symbol of integration. This is the symbol of integration. Alright, so that means if it is written f of x dx, it means integral of fx with respect to x. Integral of fx with respect to x. That means I have to find out the integration of fx with respect to x. Alright. Second, fx in this means, what does this fx means? What does this fx means? Fx means integrand, whose integration I am going to do, whose solution I have to find out. Is it clear? This is called integrand. This is called integrand. Third, what is x? X is a variable of integration. That's a variable of integration whose with respect to what variable we are integrating. X is a variable of integration. If something is written integrate sin x, that means I have to find out the integration of that. That means the process of integrating. The process of integrating. Alright. And then the constant of integration that we have already discussed, that's c. C can be any real number. This is any real number. C is any real number which we use in indefinite integrals. That we use in indefinite integral. Alright. Now we'll write the list of the formulas which we are going to use by connecting it with differentiation. By connecting it with differentiation. Let's start with the list of the formulae in relation with differentiation. The first, differentiation of x raised to power n plus 1 upon n plus 1. What happens in differentiation? The power comes in front, reduce the power by 1, n plus 1 minus 1 would be n upon n plus 1, n plus 1, n plus 1 cancel. So differentiation is x raised to power n. So I told you differentiation and integration are reverse process. It means the integration of this is going to be this. That means integration of x raised to power n is going to be x raised to power n plus 1 upon n plus 1. Is it clear? X raised to power n plus 1 upon n plus 1. It means if I have to integrate x raised to power 6, it is increase the power by 1 divided by increased power. Increase the power by 1 divided by increased power, and the arbitrary constant has to come. That I have made you clear why this c comes there. Alright, increase the power by 1 divided by increased power. Fine. In particular, in this, differentiation of x. What is differentiation of x? 1. And I know you all are very clear about the formulas of differentiation, which is a base of integration. Differentiation of x is 1. That means integration of 1 is going to be x plus c. It means if I integrate a constant, the variable comes with respect to which we are integrating it. Is this clear? Now coming to your trigonometry, differentiation of sin x. What is differentiation of sin x? Cos x. So that means integration of cos x is going to be sin x. Don't forget to write this c, because we are dealing with indefinite integration. Alright, fine. So make it clear that it is coming from here. It is coming from here. Third, differentiation of, if I say minus cos. Differentiation, what will be minus cos? Differentiation of cos is minus sign. Minus minus plus. So it's going to be sin x. That means integration of sin x is going to be minus cos x. Alright, integration of sin x is going to be minus cos x. Then fourth, differentiation of tan x, that is secant square x, that means integration of secant square x is going to be tan x plus c. All you have to remember these formulas by heart. Differentiation of minus cot x. Differentiation of cot is minus cosecant square. So differentiation of minus cot is going to be cosecant square x. That means integration of cosecant square x is minus cot x. Is this clear? Alright. Then differentiation of, we have done of secant x, that is secant x tan x. That means integration of secant x tan x is secant x. Fine. Differentiation of minus cosecant x. Differentiation of cosecant is what? Differentiation of cosecant is minus cosecant into cot. So here minus already we have. So it's going to be cosecant x into cot x. That means integration of cosecant x into cot x is minus cosecant x plus c. I hope you are able to find or develop the link between. जिसका डिफरेंशिएशन हमें आता है, इंटीग्रेशन इज द रिवर्स प्रोसेस. साइन का आता है कॉस, तो कॉस का इंटीग्रेशन इज साइन. Clear? Right now we are writing all those formulas whose differentiation we know. So their derivative will become this integration, and this is the answer. This is the differentiation, this is the function. This is the differentiation, this is the function. This is the differentiation, this is the function. Alright? Clear? Then what did we do in differentiation next? We did inverse trigonometric formulas also. We did inverse trigonometric formulas. Let's write inverse trigonometric formulas. What was the differentiation of sine inverse x? Differentiation of sine inverse was 1 upon under the root 1 minus x square. That means I'll just put an integral sign this side. Integration of 1 minus this is sine inverse x plus c. Similarly, if you remember, differentiation of cos inverse is the same thing with the negative sign. That means this can has two answers. One is sine inverse x, one is minus cos inverse x. If I say differentiation of minus cos inverse x की क्या होती है? 1 upon under root 1 minus x square minus 1 upon under root 1 minus x square minus minus plus. So this is a differentiation. It means the differentiation of under root 1 minus x square can be either sine inverse x or minus cos inverse x. देखो दोनों का differentiation है ना same. Clear? 1 upon under root 1 minus x square can be integrated as sine inverse x, or it can be minus cos inverse x. Similarly, we have tan and cot to the relation. Differentiation of tan inverse x is 1 upon 1 plus x square, and differentiation of, if I say cot, if I take minus cot this side, that is also 1 upon 1 plus x square. See girls, I have taken minus this side. Cot inverse x की differentiation क्या होती है? Minus 1 upon 1 plus x square. If I have taken negative this side, so minus minus plus, so this. That means integration of these two indicates integration of 1 upon 1 plus x square dx can be either tan inverse x plus c, or it can be minus cot inverse x plus c. Fine? Alright? Similarly, we have secant and cosecant, the relation, same relation. Secant inverse x differentiation is 1 upon x into under root x square minus 1, and differentiation of minus cosecant, because in cosecant inverse minus on that side. So this is 1 upon x into under root x square minus 1. So both, if I join together, that means integration of x into under root 1 x square minus 1 dx would be either secant inverse x plus c or minus cosecant inverse x plus c. Alright, is it clear to everyone? Fine. Now, similarly, What next we did? If you remember what all formulas we did in differentiation, we did the differentiation of Ex. Differentiation of Ex. Differentiation of Ex is Ex. It means integration of Ex is also Ex plus C. Do not forget to write. Then differentiation of log x, that is 1 by x. So that means integration of 1 by x is log x plus c. We always put a modulus with log because log is defined for positive numbers. Alright. Then last but not the least, differentiation of a raised to power x upon log a. What's the differentiation of a raised to power x? You remember? Differentiation of a raised to power x is a raised to power x into log a. If they have asked me to differentiate a raised to power x upon log a, so that means upon log a to constant, log a cancel. So that means a raised to power x. It means integration of a raised to power x is a raised to power x upon log a plus c. Alright students, so the formulae of integration should be on your tips. Right now we know only this much formulas, but integration has much more wider area. Alright, so that we will be doing by methods of integration later. Right now we have written all those formulas whose differentiation we have done, and in connectivity differentiation we have done the formulae of integration. Is it clear? And you all have to learn these formulas by heart. Let's start with geometrical interpretation of integrals. Alright. Now geometrical interpretation of integrals we have already discussed. Now let's see. If I have y is equals to x square function, dy upon dx is equals to 2x. I have y is equals to x square plus 1. dy upon dx is equals to 2x. If I have y is equals to x square minus 2, it means dy upon dx is equals to 2x. Now all these functions are giving me the same derivative. This is what we have already discussed. Now if I talk about, because now we are doing geometrical interpretation of it, if I talk about the function y is equals to x square, we all know, we have done in our class 11th also, it represents y is equals to x square, a parabola, alright, touching the origin. If I talk about y is equals to x square plus 1, again it will represent a parabola, which is 1 unit above x-axis. On y-axis it is like 1 unit above. If I take other curve, x square type, so it will again be this. Fine, if I say x square minus 2, it's gone 2 unit below. So that means the functions whose derivative is same, all the functions whose derivative is same represent the functions whose derivative is same belongs to, or you can say the functions, you can say curve because we are doing geometrical, curves whose function derivative is same belongs to same family. They belong to same family. Is it clear? They belong to same family. That means all those curves whose differentiation is same, it belongs to same family. That means these all are representing the family of parabolas. Representing the family of parabolas. Is it clear? That means my this x square plus c, this is a function. And if I generalize, because it is x square plus 1, x square minus something, irrespective of constant, so we name it as y is equals to x square plus c. So that means a function, a curve whose derivative is same belongs to the same family. They belong to same family. Is it clear? So this kind of function belongs to the family of parabolas. Belongs to the family of parabolas. Is it clear? Alright. So if now it is given fx integration dx, we can write it as capital F of x plus c. That means this is giving me all the curves which belongs to same family. All the curves which belongs to same family. Is this clear? Alright. Now there are certain properties which you need to keep in mind. First of all, this we have all done. I am just giving you in a nutshell. Like integration and differentiation are reverse processes. Are reverse processes that started from the topic from there only. Integration and differentiation of reverse process. That's why integration is called antiderivative. That's why integration is called antiderivative. Is it clear? Second, we have done right now, if two indefinite integrals with same derivative, same derivative belongs to same family of curves. Belongs to same family of curves. That's what we have done. These are have same derivative, belongs to, they're being parabolas. Is it clear? They belongs to same family of curves. Third, if I have sum of functions in integral, if I have sum of functions or subtraction of the function, it can be f of x plus g of x, it can be f of x minus g of x. So I can write down them in the separate integrals. I can write down them in separate integrals. fx का अलग से integration करेंगे plus gx का अलग से integration करेंगे and then we are going to add it up. Alright. And then similarly, fourth property, if fx is multiplied by a real number, where k is any real number, you don't have to integrate this k, this k comes out of the symbol of integral, we just have to integrate f of x. Is it clear? I just have to integrate f of x. For example, if I have 2x, I bring this 2 out, I just have to integrate x. I just have to integrate x. Clear to everyone? Alright, so these properties, formulas, everything you have to keep in mind, children. Integration, I told you, very important topic. Reverse of differentiation. Then we did the formulas of integration that you have to learn by heart. Geometrical interpretation, that means all the indefinite integrals with the same derivative represent the same family of curves. And then the properties of indefinite integration that you have to learn, you have to keep in mind while doing this topic.